The human brain is one of the smartest on the planet. But there are some things we just can't wrap our minds around. One of those is the paradox. We've evolved to think of reality in a specific way, but there are paradoxes out there that suggest reality doesn't work the way we think it does. And now some physicists think they have solved a 50-year-old paradox. But have they? And what are the other strangest paradoxes? Get ready to find out. Fermi paradox. A lot of you are probably familiar with the Fermi paradox. Fermi paradox, named after Italian physicist Enrico Fermi, who is famous for creating the first nuclear reactor. This paradox seeks to answer the question, where are the aliens? Given that our star and Earth are part of a fairly young planetary system compared to the rest of the universe, and that it's possible for a civilization to achieve interstellar travel during this time, it seems we should have been visited by some form of extraterrestrial intelligence by now. Now some say it's not a real paradox, because we can only guess that there is intelligent life out there. But the Drake equation is used in this so-called paradox to estimate the number of possible civilizations in our galaxy. The Drake equation uses 7 variables to estimate the number of detectable civilizations in the Milky Way. Voice actor, you do not need to narrate this because it will go on the screen. This gave us an idea that there could be millions of Earth-like worlds with civilizations out there. But this was back in 1961, and no one knew of any worlds orbiting stars other than our own. It was only recently that we got a good idea. In 2020, astronomers using data from the Kepler Space Telescope found there are more than 300 million worlds with similar conditions to Earth scattered throughout the Milky Way. The analysis concluded that roughly half of the galaxy's sun-like stars host rocky planets in habitable zones where liquid water could be on the surface. In fact, planets are extremely common and outnumber all the stars in our galaxy. And very soon, the James Webb Space Telescope will be headed into space to look for new potentially habitable worlds. We'll have a new video on that soon. So make sure to stay tuned here. The silent universe. Now that we know how many worlds there are, and how many possibilities there could be advanced civilizations, the question remains. Why is the universe silent? Maybe we're about to find out soon as technology advances, or perhaps we've already been visited by some faraway civilization, and just don't know it yet. There have been many unexplained UFO sightings recently, and some believe extraterrestrials are already here. Solid proof of that would put an end to this paradox. The bootstrap paradox. The bootstrap paradox is a paradox of time travel that questions how something that is taken from the future and placed in the past could ever come into existence in the first place. It's a common theme used by writers inspiring plotlines in many science fiction films, such as the Bill and Ted movies, Terminator, and Doctor Who. So let's look at one of the examples of this paradox. Imagine that you are a time traveler, but before you go on an excellent adventure, you go into a bookstore and buy a copy of Hamlet, written by Shakespeare. You then travel back in time to London during the Elizabethan era, and give the book to Shakespeare. William S. then copies the book and claims it as his own work. Centuries go by, and during this time, Hamlet is printed and reproduced countless times until a copy of it ends up back in the same bookstore that you bought it from. The question then becomes, who wrote Hamlet? By the way, for those who missed our video on parallel universes, check out the link in the description. The grandfather paradox. This is another famous paradox, which involves you going back in time to take out your grandfather. By that we mean, erasing his existence. Now, we know everyone here loves their grandparents, but this is only an example. Once again, you are a time traveler, and you pop back in time to do the deed, and erase your grandfather's existence. You then return to present time, but the thing is, with your grandfather gone, your father wasn't born, and you now realize you never even existed. Everything about you has now been erased, including all your family, friends, all your possessions, and your history. So you wouldn't have been born in the first place, so it would be impossible to do this. Now some scientists believe that if this were to happen, you would have now created an alternate timeline or even entered a parallel universe. By the way, for those who missed our video on parallel universes, check out the link in the description. Taking out Hitler paradox. Another interesting variant to the grandfather time travel paradox, going back in time to eliminate Hitler to stop World War II. This would have some interesting consequences. Let's say you have a shiny time machine, and you've got a plan to go back before things get out of control during the war, and put things right. The problem now is that the action removes any reason to travel back in time, along with any knowledge that the reason to time travel back ever existed. Acting as a time-traveling executioner simply creates a paradox, and along with the many worlds idea, traveling back in time might create a new timeline without der Führer, but the old timeline would also still exist. You might even create a new timeline that is even worse. But what would happen if you sent something back through a wormhole? Polchinski's paradox. The late, great Joseph Polchinski is the famous theoretical physicist who wrote the book on string theory. But Polchinski also came up with a potentially paradoxical situation involving a billiard ball sent through a wormhole that travels back in time. In this scenario, the billiard ball is fired into a wormhole at such an angle that, if it continues along the path, it will exit the wormhole in the past at the right angle to collide with its earlier self, thereby knocking it off course and preventing it from entering the wormhole in the first place. However, some physics students came up with solutions which avoid any inconsistencies by having the ball emerge from the future at a different angle than the one used to generate the paradox, and deliver its younger self a glancing blow instead of knocking it completely away from the wormhole, a blow which changes its trajectory in the right way, so that it will travel back in time with the angle required to deliver its younger self this glancing blow. Now here is something that will make you think about reality differently. Observer's paradox. Observer's paradox. The observer's paradox is something very strange indeed, and of all the bizarre facts of quantum theory there are fewer stranger than Schrödinger's famous fable about a cat that is neither alive nor deceased. For the record, this is a thought experiment only, and no animals have ever been harmed. The paradox describes a cat that is locked inside of a windowless box along with some radioactive material, a Geiger counter, a hammer, and a container of deadly poison. The radioactive material has a 50% chance to decay. If the Geiger counter records an emitted radioactive particle, it then triggers a hammer that smashes a vial of poison that will be fatal to the cat. However, you would not know if the cat was alive or deceased until you opened the box. And so until the box was opened, the cat would be both alive and deceased at the same time. How is this possible, you ask? This is because simply looking at matter actually changes the outcome of what happens to it. You can't know something is there unless you see it. The double slit experiment. Now you're probably saying this whole thing is very strange. But consider another observer's paradox called the double slit experiment. It is the most famous physics experiment of all time. Imagine a wall with two slits in it, and then throwing tennis balls at the wall. Some of them will bounce off the wall, but some of them will travel through the slits. If there is a wall behind the first one with slits, some of the tennis balls that made it through will hit it. Now if you mark where the tennis balls hit the second wall, you should expect to see two strips of marks roughly the same size as the slits. Sounds pretty straightforward. But in the double slit experiment, something awfully strange happens when you shine a light through the slits. Light isn't just a wave, it's also a particle called a photon. Now if you shoot a single photon at the double slits, it forms an interference pattern on the back wall as if it is interfering with itself. It's like the photon went through both slits at the same time. But this is where it gets stranger. Simply by looking at the double slit experiment, the behavior of the photons changes, as if the photons are alive and know you are watching them. We know this because if the experimenter tries to find out which slit the photon is going through, the interference pattern doesn't show up at all. The bottom line is that observing a photon can change events that have already happened. How is that possible? No one has figured it out yet. Maybe you might be the one to solve this puzzle. The black hole information paradox. Black hole information paradox. One of the biggest paradoxes in physics is the black hole information paradox, a puzzle that results from the combination of quantum mechanics and general relativity. Calculations show that physical information could permanently disappear into a black hole, allowing physical states to devolve into the same state. But this is controversial because quantum mechanics states that information can never be destroyed. Let's say you burned two different letters written on paper. Putting them back together from ash would be nearly impossible, but not entirely. The small differences in smoke, temperature, and the amount of ash would still retain information about the two different letters. The problem with black holes is they suck things up and then, over a very, very long time, radiate what they have swallowed back out in the form of Hawking radiation. Unfortunately, unlike the smoke, temperature, and ash from burning a letter, Hawking radiation contains no information about what the black hole ate. This is because all Hawking radiation is the same, which implies that black holes destroy information about the universe. So do evaporating black holes really destroy information, or does information escape as the black hole evaporates? A new generation of physicists say that information does indeed escape a black hole by their radiation, and they have identified an invisible surface that lies inside a black hole's event horizon called the quantum extremal surface. This surface appears to encode the amount of information that has radiated away from the black hole, evolving over the black hole's lifetime exactly as expected if information escapes. Apparently, something can escape a black hole. It's a problem not completely solved yet, and is a work in progress. When we find out for sure, stay tuned here and we'll let you know.